As we saw, Einstein already in 1907, back in patent office days, had thought that there would be a way to measure the redshift or blue shift of light. It would be one of the consequences of the emerging theory. But he didn't have the theory yet. By 1910, he was more convinced yet that this needed to be measured. And an astronomer that he had met, Erwin Finlay Freundlich, became fascinated by Einstein's work. As he took up his post in 1911 at the Berlin Potsdam Observatory, Freundlich hoped to be able to build a device, a building, a laboratory that could explore the redshift or blue shift of light. And in particular, Freundlich was interested in the redshift of light that would happen as light left the sun, this huge gravitating mass near us. If it was true that light was turned towards the red by leaving a gravitating body, then you should be able to look at a spectral line and compare the spectral line of, say, something from the hydrogen spectrum when it got to the Earth's surface with a hydrogen line that was generated here on the Earth's surface, and see that there had been a shift towards the red of that hydrogen line that came from gases on the sun. Over the following years, the conception of this Einstein Tower, as it came to be called, came in 1917, and it was built between 1919 and 1921. The whole building is a laboratory. You could picture its tower bringing the light down from the sun, refracting it through a prism, and sending it along to a screen. And on that screen, you would see the spectral lines, and then be able to compare them to an Earth-generated version of that same spectrum. The laboratory was designed by the architect Erich Mendelsohn. Erich Mendelsohn drew on many of his contemporary sources of artistic, filmic, and architectural modernism, but it was a modernism not so much like the hard-edged geometrical forms of the Dessau Bauhaus, but of more organic, curved lines, more expressionistic in its orientation than hard-edged geometrical. Mendelssohn, for instance, would have seen Bruno Taut's Glass House from the Cologne Werkbund exhibition in May of 1914. He certainly was very impressed by Max Pechstein of Die Brücke, the bridge, Kandinsky's Blue Rider paintings from the early 20th century. The Cabinet of Dr. Caligari came out in 1920, but it was just one of the expressions of this movement towards trying to put emotions and organic forms into the architecture itself. Erich Mendelsohn began to sketch pictures of what this Einstein Tower would be like, imagining forms that had a more curved, smoother structure, but not geometrical. He began to think of images that resonated with the kinds of things one would have seen in submarine design, coming out of the work of weapons builders during World War I, and in that period, as people began to think about aerodynamic or water dynamic designs. Josef Maria Olbricht's wedding tower in Darmstadt in 1908 was again structured around these curvilinear forms that would express something of affect in biology as well as pure geometry. The Einstein Tower itself, in cutaway, could be seen to have this vertical and horizontal structure. You could go look at the forms, for instance, of its cupola, where you could see the possibility for the telescope and lenses to bring down the solar images that would then be refracted through the prism and projected onto the wall. But you can see, too, here the expressionistic form, the more organic form than the purely geometrical that would have dominated the work that we've discussed in the relationship between the Aufbau and the Bauhaus. In World War II, the Einstein Tower was badly damaged. Work had conducted there during the war. Freundlich, because much of his family was Jewish, had to flee. He went to Turkey and no longer could direct it. But as a token of the reverence with which the astronomers there held Einstein, they put a single stone where a bust of Einstein had stood. Einstein was embodied in as a kind of physical material joke and yet tribute to Einstein in a time when no one could utter his name. Freundlich's efforts and the efforts conducted in the Potsdam Einstein Tower never succeeded in extracting a sharp measurement of the gravitational redshift. It was just too difficult to extract from the turbulence of the sun's surface. But that experiment was realized in a different form, a more purified laboratory rather than astronomical form, by Bob Pound and his collaborators in 1959, where in a tower here at Harvard, they figured out a way of taking light and pointing it down towards a very precise measuring device at the base, and then reversing the process and sending it up. And they could see, in comparing the light frequency as it got to the ground and the light frequency as it got to the top of the tower, very precisely, first within 10% and then within 1% of the Einsteinian prediction. It was a remarkable confirmation, one of many of Einstein's theories, and led to probably the first really precise measure that confirmed Einstein's redshift and blueshift work.